Hi dear students, welcome you all to the brilliant group of institution. Here we are discussing the chapter structure of atom from your grade 11 chemistry, your chapter number 2, the most important questions. As per NCERT, a lot of important questions are there. It's a high weightage chapter from your grade 11. So we are going to discuss the most important question from this chapter, structure of atom. Let us start with question number 1. There will be a statement type of questions. The main 3 principles are there in this chapter, the last part of that content numbers, right? First one is called Aufbau Principle, second one Pauli's Exclusion Principle, and third one Hund's Rule of Maximum Multiplicity. So dear all, Aufbau Principle statement is a definite question for the exam. What do you mean by Aufbau Principle? Aufbau Principle says that electrons are filling in the orbitals, 1s2, 2s2, 2p6, this arrangement, right? This arrangement, 1s2, then electron goes to 2s, 2p, 3s, 3p, then 4s, 3d, like that. What is this arrangement called? This is the arrangement of Aufbau Principle. What is Aufbau Principle statement, dear all? Study now. It is the filling of electron in the atomic orbitals in the increasing order of their energy. Once again, I'm repeating, electrons are filling in the orbitals in the increasing order of energy is known as what? Aufbau Principle. It is also called what? N plus L rule. N plus L rule. What is N? Principal quantum number, and L is the azimuthal quantum number. We are going to study each topic very detailed. So this is the statement of Aufbau Principle. So dear all, while you filling electron in this orbital, it is happen in the increasing order of energy, which means lesser energy to greater energy. Let's go for the second principle, that's called Pauli's Exclusion Principle. What Pauli's Exclusion Principle states that, dear all? Pauli's Exclusion Principle says that no 2 electrons in an atom can have. No 2 electrons in an atom. Let us consider one of the example, helium atom. Helium atomic number 2, the configuration is 1s2. In this 1s2, this is the character representation, right? First electron rotate in clockwise spin plus half, and the other one downward, what is that? Minus half spin. In a orbital, when you filling 2 electron, that first electron always the rotation is plus half, that means clockwise, and the second electron is minus half. Yes, so no 2 electrons in an atom. These are the 2 electrons in the same atom, helium. So dear all, in helium atom there are 2 electrons, right? There are 2 electrons, but these 2 electrons, at least their spin quantum numbers are different, right? First electron spin quantum number plus half, second electron spin quantum number minus half. Yes or no? So that means no 2 electrons in an atom can have all the 4 set of same quantum numbers. So no 2 electrons in the same atom can have identical values of all the 4 quantum numbers. What are the 4 quantum number? Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. These 4 all quantum numbers should not be the same for both of the electrons in the atom. That is called Pauli's Exclusion Principle. Let's go for the last one, that's called Hund's Rule of Maximum Multiplicity. What is Hund's Rule says that, dear all? When you filling electrons, when you filling electron in a degenerate orbital, which means the same, what do you mean by degenerate orbital? The orbitals having same energy are known as what? Degenerate orbital. When you filling electron in a degenerate orbital, after single occupation of electron, then only pairing can happen. See all of the arrangement. In this case, 1s2, 2s2, 2p6. If you consider this p orbital, dear all, these all p orbitals having same energy, 4 electrons I'm going to fill, okay? Here 1, 2, 3, then 4. So after single occupation only pairing is happening here. What is this mistake here? This is the correct one. What is the mistake here? 1s2, 2s2, 2p4. How they filled here? 2 and 2. Dear all, this is vacant, right? After single occupation of electron, then only pairing can happen. That is called what? Hund's Rule of Maximum Multiplicity. So dear all, Aufbau Principle, Pauli's Exclusion, and Hund's Rule definition is very important. It's a 1 mark question for the exam. Let's go for the next theory, dear all. Next question. Question number 2. It's a numerical question. Calculate the wave number. What is the symbol of wave number? Nu bar, right? Nu bar. And which one? Frequency. What is frequency? Just nu. And of the yellow radiation having a wavelength 5800 Armstrong. Dear all, wavelength is given. Lambda wavelength is given. Let's see the calculation, dear all. Calculation of wave number. What is the symbol of wave number, dear all? Nu bar. Alright, nu bar. And wave number is supposed to calculate what is given? Lambda. Lambda is the wavelength. The wavelength is given 5800 Armstrong. Dear all, Armstrong, please convert into meter. 1 Armstrong is equal to 10 to the power minus 10 meter. So 5800 is equal to 5800 into 10 to the power minus 8 centimeter, or you can write 10 to the power minus 10 meter. How to convert Armstrong into meter, dear all? Into 10 to the power minus 10. Here it is centimeter, therefore 10 to the power minus 8. You can use meter or centimeter. So, in terms of meter, what you can say? 5800 into, yes, 10 to the power minus 10. Next one. So, lambda given. If lambda given, so simple to calculate wave number, nu bar. Wave number, nu bar is equal to 1 by lambda. It is the reciprocal of wavelength. Dear all, wave number is the reciprocal of what? Wavelength. Keep in mind. So, 1 divided by wave number value, we can able to calculate. It's around 1.7 into 10 to the power 6 meter inverse. You know, wavelength unit is meter, so wave number is meter inverse because it's a reciprocal of wavelength. Next one. So wavelength, okay. Wavelength is given, wave number we calculated. Next is supposed to calculate frequency. What is frequency, dear all? Frequency nu. What is the relation between wavelength and frequency? What is the relation between lambda and nu? Dear all, C is equal to nu lambda. C is equal to nu lambda. Therefore, what is nu? That is C by lambda. Nu is equal to C by lambda. Or what is C? C is the velocity of light, you know, 3 into 10 to the power 8 meter per second divided by lambda already given. Yes, let's calculate. We are getting 5.17 into 10 to the power 14 second inverse, right? Or hertz. Nu, you know, what is a unit of frequency, right? Second inverse of hertz. So this is the calculation for what? Wave number. So wave number nu bar is equal to 1 by lambda and frequency nu is equal to C by lambda. All of you just to recover the equation once again. Let's go for the question number 3. Again, one numerical question. Calculate the energy of 1 mole of photon, you know, photon light of radiation whose frequency is given. What is the given frequency? Nu. Nu is equal to 5 into 10 to the power 14 hertz. Frequency already given. Yes, frequency, dear all, already given. What is the equation to calculate energy of photon? E is equal to h nu. E is equal to h nu. That is the equation. E is equal to h nu. E is the energy of photon. H is what? Planck's constant. Where h is called what? Planck's constant. We know the value 6.626 into 10 to the power minus 34 joule second. And which one? Nu is the frequency. H, yes, all of you study the value, okay. H value, what is H is called? Planck's constant, here all 6.626 into 10 to the power minus 34. And then what is nu? Frequency already given in the question, 5 into 10 to the power 14. Then what is energy? E equal to H into nu. But the question, calculate the energy of 1 mole photon. You know, 1 mole which contain Avogadro number of particles, right? So what is the energy? This is the energy of the photon. So what is the energy of 1 mole of photon? Multiply this energy with the Avogadro number 6.022 into 10 to the power 23. So we are getting overall energy of 1 mole photon is 199.5. So dear all, what is the equation to calculate the energy of a photon? E is equal to h nu. E is equal to h nu. Okay, let's go for the question number 4. Define photoelectric effect. What do you mean by photoelectric, dear all? This is the photoelectric effect. Can you see, dear all, this is a metal surface. Okay, you know, metals contain so many electrons. There is a radiation. There is a radiation with a sufficient amount of energy. There is a radiation with a sufficient amount of energy is fall on the metal surface. Then what happened? When a radiation with a sufficient amount of energy fall on the metal surface, there is an ejection of electron happen. There is a ejection. The electrons from the metal can be ejected. This process is known as what? Photoelectric effect. Can you make this effect into a definition? What do you mean by photoelectric effect, all of you? It is the ejection of an electron from a metal surface when a radiation with a sufficient frequency is fall on the metal surface. Is known as what? Photoelectric effect. See, all of you, for your reference, I'm just giving the definition here. Photoelectric effect is the phenomenon in which electrons are ejected from the surface of a metal, the light when incident on it. You know, all kind of radiation cannot make a ejection of an electron. There should be some minimum amount of energy to eject an electron from the metal surface. That energy is called what? Threshold energy, right? What do you mean by threshold frequency or threshold energy? It is a minimum frequency required for the radiation to eject an electron from the metal surface. All right. So, and what is the name of the ejected electron is known as? It is known as photoelectron. The ejected electron from the metal surface is known as photoelectron. Dear all, this is called photoelectric effect. And from the next question, we have to study one more data. Write the properties of photoelectric effect, dear all. This is also one of the question for your exam. What are the properties of photoelectric effect? Let us consider the diagram once again. Dear all, metal surface, radiation is falling and electrons are ejecting. What are the characteristics of photoelectric effect? All of you carefully listen. First property, there is no time lag. There is no time lag in between the incidence and ejection of electron. Whenever the radiation fall on the surface of the metal, at that instant electron can be ejected. So that means there is no time lag in between the incidence and ejection. Second one, let us consider the number of electron. Dear all, if the radiation falls with a high energy, more electrons can be ejected. One more point, dear all, if the radiation falls with a high amount of energy, the ejected electron, what is that ejected electron is called? Photoelectron. It ejected with a high kinetic energy. For each metal, there is a characteristic minimum frequency, nu zero. What is nu zero is called? Threshold frequency. I already told you what is threshold frequency before. It is a minimum frequency for the radiation to eject an electron from the metal surface. Alright, so these are the one. So in order to eject an electron from the metal surface, at least threshold energy required, minimum threshold or more than that. If the energy, if the frequency of the radiation less than that frequency, it cannot make an ejection. So these are the properties of, dear all, study what is photoelectric effect and photoelectric effect, their properties, and even numerical also there we can discuss from the other question. Next question, dear all, this is the numerical question they can ask from photoelectric effect. The threshold frequency nu zero is already given around 7 into 10 to the power 14 second inverse, and calculate the kinetic energy of an electron emitted when radiation of frequency is given. That's nu is the given frequency and nu zero is the threshold frequency. It's already given. Question to calculate what is the kinetic energy of the ejected electron. We know already the name of that ejected electron. I already specified here. All what is that ejected electron is called during photoelectric effect? Photoelectron. We are going to calculate what is the kinetic energy of the ejected electron. We have the normal equation for kinetic energy. What is the equation for kinetic energy? That is kinetic energy K is equal to half mv square. Why I mention here me? Because the ejected species is an electron, so mass of electron we can consider. Half mv square is equal to h into nu minus nu zero. That is the equation. Dear all, me, what is me? Mass of electron. What is v? The velocity. And h is the Planck's constant. Nu is the given frequency. And nu zero is the threshold frequency. Let us substitute, dear all. What is h? H is a constant, you know, 6.626 into 10 to the power minus 34 into what is nu? What is the given frequency? 1 into 10 to the power 15 minus what is nu zero? 7 into 10 to the power 14. So let us substitute. We are getting the value while simplification, dear all. We are getting around 1.98 into 10 to the power minus 19. It is an energy. So the unit is what? Joule. So what is the equation to calculate the energy of the ejected electron, dear all? Kinetic energy half mv square is equal to h into whole nu minus nu zero. Hope you clear? This is the numerical from photoelectric effect. Let's go to question number 7, dear all. Another question from numerical. What are the frequency? That means nu and wavelength lambda okay, of a photon emitted during a transition from 5th level to 2nd level. Dear all, an electron is traveling from 5th energy level to 2nd energy level. So what is the initial level? 5th. What is the final level? 2nd. Correct? Let me write Ni is the initial level, Nf is the final level. So what is Ni here? 5th, and Nf is the 2nd level. Clear all of you? If so, what is the equation to calculate frequency and wavelength? Direct equation is not there. First we have to calculate what is the energy difference between these two levels. What we have to calculate? What is the energy difference between this 5th level to 2nd level? What is the energy difference that we want to calculate? Let's calculate, dear all. The delta E is the energy difference between these two levels, that is calculated by 2.18 into 10 to the power minus 18 whole into 1 by Ni square, initial level square, minus 1 by Nf square, the final level. Let us substitute the value 2.18 into 10 to the power minus 18, 1 by, what is the initial level? 5th, so 5 square, minus 1 by 2 square in terms of joule. So it's around minus 4.58 into 10 to the power minus 19 joule. That is the delta E. If you know the difference in energy between two levels, dear all, we have an equation to calculate the frequency. What is the equation to calculate frequency? Nu is equal to delta E by H. Change in energy by the Planck's constant H. What is delta E? That is minus 4.58 into 10 to the power minus 19. And what is Planck's constant? 6.626 into 10 to the power minus 34. So frequency is what? It's in terms of positive value, 6.9 into 10 to the power 14 hertz. If you know frequency, we have an equation to calculate wavelength. Can you recover fast? That we already discussed. What is this? This is frequency. By knowing frequency, we have a simple equation to calculate wavelength. What is the equation to calculate wavelength? You know, C is equal to nu lambda. C is equal to nu lambda. So what is the wavelength lambda? Lambda is equal to C by nu. What is C, dear all? Velocity of light, 3 into 10 to the power 8 divided by the given frequency. Yes, it's around 434 nanometer. So dear all, just to recover the equations once again, all of you. Here an electron is transmitting from what? 5th level to 2nd level. So we calculated the energy difference was, that is delta E. By knowing delta E, we already calculated what? Frequency. By knowing frequency, we can able to calculate the wavelength also. Hope you clear? This is the method. Next question, dear all. Calculate the energy associated with the first orbit of helium plus. You know, Bohr's model is only applicable to hydrogen and hydrogen-like atom. You know, hydrogen-like atom means the one which contain only one electron. Helium, you know, helium atom contain 2 electron, but helium plus, which indicate it lose 1 more electron. So what is left? 1 electron. So helium plus is a 1 electron system. And what is atomic number of helium? You know, 2. Okay, and what is the, just in the previous question we calculated the energy difference between two level, right? Delta E. Here they are not asking that one. Here they are asking what is the energy of a particular orbit. What is the equation to calculate energy of a particular orbit, dear all? Energy of nth orbit is equal to minus 2.18 into 10 to the power minus 18 Z square by N square in terms of joule. What is Z? Is the atomic number of the element. What is atomic number of helium? 2. And what is N? Is the energy level. They are asking the energy of first orbit, dear all. So N value is equal to first 1. So dear all, for helium, what is the N value? What is the level they are asking? The level is first orbit. Therefore, N value is equal to 1. And what is the atomic number of helium? Z is equal to 2. Let us substitute E1. That because of that first energy level, right? This is nth orbit energy level. So here, what is the first orbit of energy? Minus 2.18 into 10 to the power minus 18. 2 square divided by 1 square. That's around minus 8.7 into 10 to the power minus 18 joule. This is the energy equation. Question not over. Question, what is the radius of this orbit? Dear all, this equation is given by Bohr's theory. Bohr gives the energy of nth orbit. Similarly, what is the radius of nth orbit? Radius of nth orbit is equal to, Rn is equal to 0.0529 into n square by z in terms of nanometer. Dear also, let us substitute 0. N value is equal to 1, z value equal to 2. That is common because question not changing, energy level not changing. So radius of nth orbit is equal to 0.0529 into 1 square divided by 2. It's around 0.026 nanometer. So dear all, study what is the energy of nth orbit and radius of nth orbit and just directly substitute. That's it.